Hello everyone, welcome to our solution series on UPSC Civil Services Mathematics Optional Solution 2019. We have already covered ordinary differential equation, partial differential equation, vector calculus, complex variable and real analysis. Today we are going to do calculus. Calculus was asked for 70 marks. So this 70 marks, when I am calculating it, I add all of those questions, all 4 questions. So that is the maximum marks. So that was asked for 70 marks in 2019. In 2018 it was asked for 83 marks, and in 2017 it was asked for 60 marks. So before I start solving this question, I must read this question. This is question number 1a, that says let any function from whose domain on closed interval is 0 to pi by 2 to R be a continuous function such that f of x is equal to cos square x 4x square minus pi square, and x lies on closed interval, that is 0, but on open interval at pi by 2, and we have to find the value of f pi by 2, and this was asked for 10 marks. Before we start solving this question, was this question on predictable lines? Yes, every year mostly such questions come. So we can see here in 2018 they have asked the limit questions or the indeterminate form question, that is limit z tends to a 1 minus z tan inverse tan pi z by 2. Second, also this is also we have to find the limit, that is limit n tends to infinity 1 by n square summation r is equal to 0 to n minus 1 and under root n square minus r square. These 2 questions were asked in 2018, and in 2015 limit x tends to a 2 minus x by a to the power tan pi x by 2a. This was asked in 2015, and in 2018 limit x tends to a ln 1 minus x cot pi x by 2, 2018. So the point I am trying to make is that if you know the syllabus, if you know the areas they definitely ask, and if you just solve those previous year questions, then we are in a very good position to get those easy answers to those questions and get easy marks. So I am going to solve this question, that is question number 1a. It is saying that it is a continuous function. So we can write here that f of pi by 2 minus is equal to f of pi by 2, because it by the virtue of continuity. But here it is on open interval, so we will not write it equal to f pi by 2 plus, because it is an open interval. So this is not to be factored into. So we have to find the value of f pi by 2. So it is f pi by 2, we can write this as limit of x tends to pi by 2 minus f of x. We can write this as limit h tends to 0 cos square pi by 2 minus of h and 4x pi by 2 minus of h whole square minus pi square. Now when this is x tends to infinity, so we can write this as pi by 2 minus f is equal to h. So we can write x as pi by 2 minus h. So this is what we have directly written over here. Now I am going to solve this. So this amounts to limit h tends to 0. This is our sine square h, and this becomes, we can simplify this becomes pi square plus h square minus of pi h minus of pi square, and I have forgotten here 4, pi square by 4. So this gives me limit h tends to 0, this gives sine square h, and here this is pi square plus 4h square minus of 4 pi h minus pi square. So this get cancelled. So we can readily see this is in 0 by 0 format. So we will simply apply the L hospital rule. L hospital rule when we are applying, so we can write over here limit h tends to 0. So we will take the derivative. This is 2 sin h cos h. This becomes 8 h minus 4 pi. Alright, so we can see that sine 0 is 0. So you can write over here 0, and here 8 into 0, 0, 0 minus 4 by pi is minus 4 by pi. So we get the answer as 0. So this was the answer, that was 0. Now I am going to take the next question. So this is question number 1b. Let f, that is domain r square that goes to the range r square to r, be a function, and AB belongs to domain D. If fx is continuous at AB, then show that fxb and fay are continuous at xa, x is equal to a, and y at y is equal to b respectively. 10 marks. Now if you will recall, the same question, same sort of question is asked for solely continuity and differentiability in paper 2, that is real analysis. That is also the question number 1b for any function. So if you know this concept, you are going to doubly benefit on paper 1 and paper 2 in this year, especially 2019. So we will start solving this question. So a function, you have to write the theory very well. A function fxy is continuous at a point AB if limit xy tends to AB fxy, that is FAB, that is, as x tends to A and y tends to B, my fxy will tend to FAB. That is the key point. So in other words, I can say a function fxy is continuous at point AB in the domain, in the definition of domain for delta greater than 0, howsoever small, that is to be mentioned, howsoever small, in the neighborhood n of at point AB, that is fx mod fxy minus of FAB is less than epsilon. Alright, such that double mod xy minus AB is less than delta, for some delta is function of epsilon. Now the same concept we have used in real analysis, question number 1b. So till here the points are very similar. So now we have to further proceed with this concept, and we have to prove that fxb and fay are continuous at point A and B respectively. So I will take some neighborhoods. There are a lot of things we can take, circular, rectangular, but here the functions seems to be linear fxy, that is polynomial. So I will take a rectangular neighborhood, and this is my point, say AB. This is x-axis, this is y-axis. This is, if I call it delta 1, and this one is delta 2. So I can write this as fxb minus fab is less than, you will just wait here. So we can see here that mod of x is less than delta 1 and mod of y is less than delta 2 epsilon. So here all we have to prove that it is less than epsilon. Now when my y coordinate, that is constant, then the whole notion of this being as a function of delta will vanish. So we will only be left with delta 1e. So delta 1e depends on this parameter epsilon. So we can write this as the thing, and hence we have proof for this part with the help of this diagram. Similarly, if I write mod of f ay minus f ab, again I will wait, and I will see here my x is constant, x is equal to a, so this will be omitted. All that is left with is that here we can write this as, here we are left with, so only one parameter on this parameter it is, that is epsilon. So we can write again this as epsilon. So this is how we have to prove, and this will ask for 10 markers. The point I am trying to make is that if you know continuity and differentiability concept of two or more variables, and if you apply it in simple terms and write the theory well, then you are going to get good marks for it. Now I am going to take the next question. This is question number 2a. Is f of x is equal to mod cos x plus mod sin x differentiable at x is equal to pi by 2? If yes, then find its derivative at x is equal to pi by 2. If no, then give a proof of it. This is asked for 15 marks. So the point over here is that basic idea of differentiability we must know. So first of all, if we illustrate it by graph, because in calculus a graphical approach is very important because it gives a very clear picture. So first of all, if I will write this f of x, and I am going to talk for x less than pi by 2 and greater than. So we know in that quadrant first this cos is positive and sine is also positive. But here pi by 2, it is greater than pi by 2. So here obviously cos is negative and sine is negative, positive. If you will draw the graph, you can see it very easily. So here at 0 it is 1, this is cos, and this one is sine. So we can see from here. But if we can plot this graph mod cos x plus mod sin x, then that will give us more better picture. So this is the graph of mod cos x plus mod sin x, but we are only concerned with pi by 2. So what we can do, we will only talk in terms of, this is pi by 2 and this is the value greater than this. So this is the point. So we have been asked, so from the diagram itself we can see that it is not differentiable because it is a sharp point, and here if we take the tangents, there are a lot of tangents that can be drawn. And also for any function to be differentiable, their rate of change should exist finitely, and that should be equal to the either side of the limit that will be taking place. So this is the graphical understanding of this, because we have to give a proof of it. Yes, it is not differentiable. Now this is the graphical approach that I have said, but I am also going to write it analytically. For any function to be differentiable, we must know that is it continuous or not. So we will check its continuity. So if we take this point at x is equal to pi by 2, then we can write f of x value. This is cos pi by 2 is 0, sin pi by 2 is 1. And here cos pi by 2 is 0, sine pi by 2 is 1. So we can say that yes, it is continuous. Now our another approach is to go for our differentiability. So we are going to take the derivative of this one, f of x. So this is how much? Minus sin x plus cos x. This is again sin x plus cos x. Alright. So at pi by 2, if I will check, I can get my answer. This is pi by 2 is 0, this is minus 1, this is 1. So we can readily see that it is minus 1 here and 1 here. So analytically we can write it that way, and graphically, as I have illustrated before, you can do it like way. So graphical understanding in calculus is paramount. If you draw the graphs, if you illustrate it very well, then you are going to get very good marks. So I am going to take the next question. Question number 3a. We have to find the maximum and minimum value of function f of x, that is equal to 2x cubed minus 9x squared plus 12x plus 6 on the interval that is closed 2 and 3, and it was asked for 15 marks. Now this is a very simple question, class 12th question. So before we solve this question, what are the demands of this question? If we are able to illustrate it graphically, then we will obviously get more marks for that. So first of all, I will try to draw the graph for this one. This is the rough sketch. You can see that it tends from minus infinity to plus infinity, and at 0 the value is 6. Okay, this is some point. This is the minimum point, we can see from the graph. So whatever will be the value of this point, that will give us the minimum value over here. And here we have to confine ourselves to 2, 3. So we are going to write the function f of x is equal to 2x cubed minus 9x squared plus 12x plus 6. So if I take its derivative, this gives me 6x squared minus 18x plus 12. That is equal to 0. So if I take 6 common, I can write this as x squared minus 3 of x plus 2. So I get this as 6 minus x minus x minus 1 x minus 2 is equal to 0. So these are my points. These are my critical points 1 and 2. 1 I am not going to take because we have given this has to lie between 2 and 3. So I will discard this one, discard it. So my area of interest is between 2 and 3. So I will check at point 2 and point 3. So this is the graph. Now I am going to plot. I am going to take this as point 2, point 3. You can see over here f dash between 1 and 2. What is the value? Between 1 and 2, value is negative. Here positive. Here also positive. So what we get is that it is monotonically increasing from 2 towards infinity. But our concerned area is only this one. Okay, so this gives me, this sine graph gives me the area of our consideration. So I will check my value at f dash as 2. F dash at 2 is, we can see here, if we put here is 2, this will be 0. What is f dash of 3? F dash of 3 will give me 6 into 2 into 1, that is 12. So f dash of 3 is greater than f dash of 2. Quite apparent from graph as well. So we can surmise, we can say that minimum value will be at 2 and maximum value will be at 3. So if this is the point 20, then what is the value? So f minimum is equal to of f at 2. So if you put over the value, we will get this as 10. So we can write this as 10. Okay, and our next point of consideration is 3. So whatever will be the value, so f max is f3. If you put this value in this one, we will get this as 15. So this is how we have to find the answer. Definitely it's a very simple question, we can get the answer. But once you interplay with the graphs, that what graphically it mentions, what are this range and domain, and how the time change is happening. This is basically the fundamental question. Because it was asked for 15 marks, the more you will illustrate in better manner, the more marks you are likely to get. Now I'm going to take the next question. Question number 4C1. If u is equal to sine inverse under root x to the power 1 by 3 plus y to the power 1 by 3 divided by x to the power 1 by 2 plus y to the power 1 by 2, then show that sine square u is a homogeneous function of x and y degree minus 1 by 6, and hence show that x square dou square u by dou x square plus 2xy dou square u by dou x dou y plus y square dou square u by dou y square is equal to tan u by 12 into 13 by 12 plus tan square u by 12. Was asked for 12 marks. Before I start solving this question is a very simple question, and it is a part of the syllabus Euler homogeneous equation. Lot of question has been asked in previous years. So in 2010 they have asked that to prove for a homogeneous function with order n, degree n, x dou f by dou x plus y dou f by dou y is equal to nf. We have to prove this, and again x square dou square f by dou x square plus y square dou square f by dou y square plus 2x y dou square f by dou x dou y is equal to n into n minus 1 into f. This is the general form of this point. So this is a repeated question asked in 2010. So if you know the fundamental framework as to how to solve any question with regard to this, then we apply and we get the answer. Another question, if z is equal to x f y x plus g y by x, then we have to show this dou square x square dou square z by dou x square plus 2xy dou square z by dou x square plus y square dou square z by dou y square is equal to 0. Again here we can see here the degree is here n is equal to 1. So 1 into 1 minus 1 is 0. So if we know this general format, we can do any question. That is the point I am trying to make. Always have a general understanding of any concept. Apply it, you will get the answer. So this question could also have been done. And thirdly, this is for point 1. So here u is equal to f x by a, y by b is equal to z by c. Then prove this x dou u by dou x plus y dou u by dou y plus z dou u by dou z is equal to 0, asked in 1996. So point is very simple, that here n is equal to 0, that is nf. So this and this one, if you have the general proof for this one and notion how it is done, then you can very easily solve this question. So now I will try to solve this question. Point to be noted is that the general framework for this one, the same thing we will be applying for this one. So there is nothing new in this. So we have given u is equal to sine inverse. So I will write this sine u as some function f, and I will write this as x 1 by 3 I will take outside. So this is 3 divided by x half I will take outside, and this is whole to the power half. So if we take the LCM, this is, if we take this fraction out, this is 1 by 3 minus 1 by 2. So this gives me 6. So minus 6 divided by 1 by 2. So this gives me 1 by 12. Some function g y of x. So our n is how much for this one? So we have to take this function sine u, but here we are asking for sine square u. So if I take sine square u, then this becomes x to the power 1 by 6, this function. So you can take any function here. So we have shown this as its degree is minus 1 by 6 sine square u. Okay. Now I will proceed to find this value. So we know that x dou f by dou x plus y dou f by dou y is equal to n of f. Alright. So here we are given n is equal to minus 1 by 6. Okay. So here we have to proceed that here f is sine u. So I will write this as sine u plus y sine u divided by I is equal to nf. No, we have made a mistake here. This is the degree of this one, but what we are getting for the general f, we are getting n is equal to minus 1 by 12. This was for this one, so this is minus 1 by 12. So this is gives me 1 by 12 f. This is sine u. So we can write this as x cos u dou u by dou x plus y cos u dou u by dou y is equal to minus 1 by 12 sine u. So we can write this as x dou u by dou x plus y dou u by dou y is equal to minus 1 by 12 tan u. This is for the first term. Now what I will do, I will differentiate this equation partially with respect to x, and again I will differentiate this equation with partially with respect to y, and I will add both of this, and then I will get the result that we are trying to seek. So if I differentiate this one, equation 1 partially with respect to x and y respectively, and add. So this will be x dou square u by dou x square plus dou u by dou x plus this one gives me y dou u by dou x dou y is equal to minus 1 by 12 sec square u dou u by dou x. Okay, and now I am going to differentiate it with partial respect to y. So this will give me x dou square u dou x dou y plus dou u plus dou x dou x into, this will give me y dou u by dou y plus y dou square u by dou y square is equal to minus 1 by 12 sec square u dou u by dou y. Now I will not add it, I will multiply these two equations, this with x and this with y, and add this. So when I am doing it, this become x square, this become x, this become xy, this become x, this become y square, this becomes y, this becomes y, this become y. Now if I am going to add all of this, then I will get, this gives me x square dou square u by dou x square plus y square dou square u by dou y square plus 2xy dou square u by dou x dou y, and we will take this 2 are common on both sides, so we will write this as x dou u by dou x plus y dou u by dou y into minus 1 by 12 sec square u. Okay, and we know this value is minus 1 by 12 tan u, and this we can write this as minus 1 by 2 sec square u. So this one will cancel, so we get 12 tan u. Okay, and we have forgotten to take this one common, so I will just rewrite it once more. So I am just taking both these in the same side, so I will write this as x dou u by dou x plus y dou u by dou y. This is common, so when I am going to take this one on that side, this gives me minus 1 by 12 sec square u. So this is how much? Minus 1 by 12 tan u, and minus sign I can take outside. I can write this as 1 plus 1 by 12 sec square u. So this I can write as 1 by 12 tan u. If I will change this to tan, so I will get this as 12 plus 1, so this will become 13 by 12 plus tan square u by 12. That is, if I will take this one, this is going to give me 1 by 12 tan inverse u plus 1. So I am going to take this one, and so this becomes, so this is my answer. Now I will take the last question for the session. So the question is 4c2. We have to use Jacobian method to show that if f dash x is equal to 1 by 1 plus x square and f0 is equal to 0, then f of x plus f of y is equal to f x plus y by 1 minus xy. It is asked for 8 marks. So what is the approach? So if I take this as alpha, and if I take this as beta as x plus y by 1 minus xy, and if I find this Jacobian dou alpha beta by dou xy, alright, so this gives me dou alpha by dou x dou alpha by dou y divided by dou beta by dou x dou beta by dou y. Alright, what is dou alpha by dou x? Dou alpha by dou x is f dash x. What is f dash x? 1 by 1 plus x square. What is dou alpha by dou y? F dash y. Similarly, we can say that this is 1 by 1 plus y square. Now with regard to beta, beta is x plus y by 1 minus x square. So if you take dou y, dou beta by dou x, that means you have to differentiate with respect to x partially. So I can write this as 1 minus xy. I will take, and this gives me 1, and again I will write this as x plus y, and I am differentiating with respect to x. So I will write this minus y. So what I get over here is 1 minus xy minus minus plus. So this gives me xy plus how much? Y square. This will be cancelled. So I get this as 1 by 1 minus x whole square. Now if I take dou beta by dou y, dou beta by dou y. So same thing will happen, 1 minus xy whole square, 1 minus xy we will write, and we are differentiating with respect to y, so this will be 1, and again 1 minus xy. Now here it will be minus of x. So we will get our result as 1 plus x square by 1 minus xy whole square. Alright. So when we write this, we will write this as 1 by 1 minus x whole square minus 1 by 1 minus xy whole square. So this is equal to 0. So Jacobian comes as 0. So that means alpha and beta are functionally dependent. So there is a relationship that is functionally dependency is on alpha and beta. So I will say that alpha and beta are functionally dependent. This is the prime understanding of Jacobian in the syllabus, that a Jacobian, if Jacobian is 0, then those functions alpha and beta are functionally dependent. So we can write this as alpha is equal to, say, g beta, and I have taken my alpha as fx plus f of y, and I will write this as g, and my beta was, I will write once more, I have taken alpha as fx plus fy and beta as x plus y divided by 1 minus xy, as you can recall. So I can write this g beta as g x plus y 1 minus xy. So if I put y is equal to 0, so this become f0, and g is, this is x divided by 1. So what we are saying is that we know f of 0 is 0. So f and g are nothing but the same function. So hence we can say that f of x plus f of y is equal to f of x plus y divided by 1 minus xy. Now this is the method you can have done by taking some function as tan inverse and y as some tan inverse or beta. That also you could have taken in polar form also, but they are not asking you the calculus fundamental part. They have specifically mentioned this Jacobian method. If you are not going to use this method, definitely you will get 0 marks, because they are asking the particular method. So this is the concept. In UPSC, whatever is in the syllabus, if you know the concept right, if you know this procedure and what they are asking you to do is by this method. So please do it by this method. Establish the relationship, say it is functional dependency and how they are dependent, and at the end they come as same, and hence we are able to illustrate this function proof. So with this I end my solution series on calculus, and this was the last question. Please like, share and subscribe. This endeavor of mine is to give you a credible and good solution and even alternative solution, but because of the paucity of time and my association with other activities for mathematics has really made me very difficult to do it on a regular basis. But I will try to keep my best to give you the solutions and the topical questions and their solutions and some concepts which are very pertinent and very important for civil services examination. Please spread this content so that it could reach out to those people who are in rural areas, who are marginalized, who cannot afford to come to Delhi and have classroom classes. So my purpose or my intention is purely to serve people who are really wanting to study. So thank you once more.